Hi. Um, today's lecture is the Linux, one of the strongest Linux feature, which can control user access. Remember that Linux is a multitasking operating system that can be used as a server serving multi-concurrent users. So each user create and manage files and um, his or her own file structures. So a student can create directories which can contain files and subdirectories and so on and so forth. So each files and directories can be controlled and managed selectively for users to access. So today we will look at one of the advanced Linux feature, which is a file permission and access control. All right. This is a slide that you can check out from Blackboard. Um, so I'm going to follow this a little bit. Um, and also I'm telling you that my lecture follows the textbook, the recommended textbook, which is on your syllabus. So pretty much follows that one, so you don't have any specific difficulties as you follow that. As far as you have a platform available, all right, this monitor, the screen, if you see, this is the MacBook monitor. I I mean our students have I think about 70% Windows based platform and 30% Mac users. um, Diverse. So in order to serve diversity of our students, we set up a lab server. So we have a lab server running on Ubuntu operating systems. In order to get in that Ubuntu lab operating system, then you need to come in first to VPN, virtual private network. For that, I gave you already VPN ID and password. So once you are in VPN network, then you can log in the lab server Ubuntu. For that, I also gave you individual login ID and password. So lab server is available for you to access if you have Windows operating systems. From the Windows, you can currently we have a VPN um, for Windows version only. Um, and the Mac users, which I am going to show to you because a few of our students are having difficulties to work on Linux operating systems. So some students set up a virtual box and then set up another Linux operating systems, which is it's not really uh, extremely bad idea, but um, but not well. Mac is running on Linux kernel, so it is already available. So we do not need to build another uh, virtual machine, and on top of that, another layer where you can build a Linux box, which is redundant. So, um, so this module, I'm going to use um, um, so-called Mach version of Linux, which is developed, I think, about 30 years ago at Carnegie Mellon University, which was adopted by Steve Jobs when he founded the first um, student affordable the Unix machines. So 30 years ago, the Unix box, the cheapest one is about $10,000. Cheapest one. Usually, school has, for example, Unix lab. Then uh, needs, I think, $1 million to build a Linux lab. Some school has 10 Unix lab. Then $10 million needs to be invested. So many good sized universities provide that. Uh, so the problem at that time was that students cannot do that at home. Students needs to be in school 24/7 to do homework. If homework assignment was based on Unix operating systems, right? Which is good. I mean, uh, the school offers 24/7 the facility access, so students stays all the time in the lab of the university. But anyway, um, so first time the cheapest Unix box was released by Steve Jobs, which was about $3,000. It was really fantastic, and it's like a shock, and it's like a blessing to computer scientists. So many, not many, uh, I was not able to, but some students purchased that. Okay, $3,000. The operating systems built on that next, the so-called the next, NEXT, next operating systems, next machine is Mach, okay, which is another distributor of Linux, Linux kernel. So after that, all of the products invented by Steve Jobs uh, have same kernel, which is Mach, which stemmed from Linux, that goes to your MacBook, for example, like this, and also even your iPhone operating systems. Um, so that is still there. If you develop um, some application program using C programming languages for um, Apple-based applications, then you can see uh, some of the namespace called the next step, NEXT, STEP. That's stemmed from that operating systems, next operating systems, which is a Mach. MACH, right? So, so Linux that we are using right now, or particularly Ubuntu, um, which is on our lab server, and also Ubuntu Mate that I ask you to build on your Raspberry Pi, and also Mac users already blessed because Mac has already built in. So you don't need to go away from your MacBook. It is already here. So you can simply use it. So part of the reason that I am using and demonstrating my lecture on MacBook is for Mac users. So you are blessed. So you simply use it. And also to everyone, and I'm telling you that they are the same kernel of operating systems. So not exact, not I mean, they are not 100% different. It's not like a difference between Linux and Windows. Windows, I mean, Linux is Linux. Little bit of language is different, okay, but not even more than 50% of them are different. So many of uh, uh, the command that I am using still available here on Mac. But I'm telling you that not 100% because it is not really Ubuntu. Even Ubuntu operating systems, depending upon the version, so later version might include more um, commands than command means that is nothing but software, right? Than the earlier version. So each version has a little different. So there is no such 100% same, but they are basically compatible. That's what I'm going to telling you. Okay, now those who have Mac operating systems, how can you get the terminal? All right, there are many ways, but those who have a Mac right now, those who have a Raspberry Pi or lab Ubuntu, do not have to worry about right now. You simply uh, still follow me. Okay, so holding down Command button next to Command button there is a space bar. So holding down Command button and hit space bar, then there's a search text box. There you can type terminal. Okay, when you type TE, then you can see the terminal. This term is very similar to PuTTY for um, um, the lab server users through VPN, and also Raspberry Pi users. You can also choose the, the Ubuntu Mate terminal from application menu, right? Then that is very similar to this, right? So click that. You simply hit and return back return. Then you have this. Let me see. You can see. Okay, so we can people command and plus sign. This is handy. Oh, this is big enough, right? Again, if you want to make another terminal, then while you're having this, you can press, I think, Control N, and for new, or not Control, but Command N. All right, so you have one more terminal, and you can more and more and more. All right. So here, the class notes. So if you want to see who, then you can tell me, oh, there's a Jae-yoon. okay, which is me, and host name, then well, whatever that, right? And who am I? Then Jaeyoon. And if you to type uname, then the Darwin. Darwin is a specific operating systems. It's a name of the operating systems of the Mac. Okay, an ID, then ID of me here, and the group ID is that it's automatically generated, but you can manage it, right? For example, here, let me reduce the row. Meanwhile, I'm going to increase this a little bigger. I'm going to, okay. So this group ID and user ID, they are from, see, this is also, it's nothing but Linux. So if you say pwd, then it's users slash Jaeyoon. The structure here is not the same as Ubuntu. Remember the user is under home directory in Ubuntu, but here Mac OS 10 is like this. If you want to go all the way up, then cd and slash forward slash, then that is all the way up. If you type ls, then you can see also say etc dev, so device, and bin users, so instead of homes, and the others we have a home also, net, opt, sbin, temp, usr, var. Those are the common with other operating systems. But this Mac is designed for um, uh, mainly, I mean, practically a single user. So we have separate the directory. It's called the application library network systems. So those are the thing that you can see. For example, here find the button for Mac users. Then you have here applications. Yeah, basically this is that one application. Okay, this is the application, and also library and network. They're all in this etc. Since we are working on the user access control, first the access control is so user login and password. So how to create users as a system administrator, Linux administrator, will be discussed in another separate module. So that's not for today. So by creating, as you create users, you have to do a couple of the following things to specify. For example, user ID, and you need to decide whether that user can come in my server and use a file system, which means create and store something. It's not like a Windows system. Windows system, once you create a user ID, then a user can do so many things. But Linux operating systems and Unix operating systems, it's not like that. You can give user access to create a file or not to create a file. So do not provide some type of users any file systems. That person can come in my system, but no space for him or her. That is also possible. Okay. For those who wants to download the file only, okay, or upload. That is one. Another one is when the user comes in, then we need to decide which um, uh, version of operating systems that we provide. It's not really operating systems. We call that shell. Which shell uh, services can be provided? C shell, Bourne shell, and a couple of shells available. So that is one thing. And also, we need to decide, hey, this guy is in, by the way, we have a multiple different groups. Can this students be in what group? Okay, student group, or faculty group, or researcher group, staff group, and so on and so forth. You can see that in our lab server. Then you guys are in a specific group. I believe that is maybe it's IASP 321 or 221, that group, for instance, or 417 also, because we have different years. And also we can set expiration date. So not all users, once created, stay there forever. Oh, that is a Windows operating systems. It's not Linux. We can set expiration, and we can expand also, right? So, and part of such stored in the following file. If you change etc, like etc, then there is a file called the password. So if you say ls, if you type ls, then you can see only the name of the files. If you type ls-l, then you can see also some of the code, right? Codified the privileges. This part is something that we need to learn. Okay. Me, I'm the root. Wow, good, hallelujah, right? And then this is group will, and then this is size of the file, whatever that is. And if you see here password, here the password file. So will 5925, this is the size of that. It was created, that is a timestamp, and this is a file name, password. So if you see cat password, then you can see those things, right? If there are long line of the file, like our lab server, because I still keep the user IDs of last year and further down, although automatically their access was expired, and yours also will be expired, I think on a specific date, I think December 30 or 31st. Okay, on that date, after that date, you cannot access our lab server. That's for security reason, right? So we are our major is cyber security. So you understand that. Let's say password, the size of password is too long, so I do not want to scroll back and forth, but I want to. Can I get it quick? Yes, you can. You can grab it, right? So that we can do here pipe and then grab. What do you want? If we want to see Jae-yoon, then what happens here is the cat password. Then before this pipe, there is a command, right? So that command is executed, and therefore there is some return. Whatever the return from the command, okay, first command, that will be the input to the second command. Second command. I want to grab some pattern keyword. I want to grab some pattern from some source. I don't specify the third one here, right? Instead, this input comes from the first out. Okay, so hit enter. There's no JUn. Oh, there's my may not be here. Let's see. What is available? But for Ubuntu, you will have that. You don't have to worry about. But this particular cases, there's no shadow. There's no. Okay. But anyway, that user creation will be discussed in the separate module. So that's not for today's. If I say ls space minus l, then there's that gives me a long list of the content. And then when I do uppercase F, then it indicates whether it is a directory. So this is a directory, security, there is a directory. So maybe that is under security. So let's try to find it. I'm not going to spend much here because we do not have to do. Oh, there is enough for that. Let's do sudoers .d cd cd. Let's see, where are we? Security. So cd sudoers.d. So nothing is here. It's not. So SSH. Security record PPP. First fix. The pen open LDAP. Maybe open LDAP. There's some password about. All right. So, but anyway, in Ubuntu, you can see it very quickly. So this is for the ID here. Date. That is also Saturday. That date, and PS. Like this is multi-processing. So can we see the processes? Let me see, man is available here. Yeah, man is also available, manual. So if you see process status, then you can see all of those. So using that, if we want to see PS minus AUX, X is not available on this Mac, but AUX is available on the Ubuntu. So let's say AU. AU is not still, so minus A. So it gives us some of the process that I am currently using. See, this is my bash shell. Okay. So what are the options that I can use? Information of running with this real ID. SG. Maybe L, that I can see more. Yeah, I have more. So I have A, L, and not much. So memory usages. If you want to see memory usages, then you can see also minus M, right? So which ones uses how much memories that can be seen like this. All right. So that is first slide, and the second slide. Okay. So here, the environment is like environment variables are set usually. So if you say type minus L, come back here. So this is my home, right? PWD, and ls, then we have this, and ls minus A, then you can see all, including hidden files, right? So I have a lot of hidden files. For example, bash rc. Bash rc. Okay, so if you want to see bash rc, then the file name includes, there's a prefix which is dot. Dot means myself, right? But myself, if we have a dot in the file name, then that is a hidden file. You cannot see that simple list command. So that is there. Right now, this dot bash rc has only this path expression. Okay, whatever path that I have, if you want to see, hey, I have here path. So including this, I want to put this more. Okay, user usl slash local and usl slash local slash bin. So more command may be available. For example, if I go to that, usl local bin, those are the commands if I not available if I do not have this path expression. But now I'm able to run all of this. This is the extended version of the thing. For example, PIP. This is the installation program for Python. That is also available. PyPy. Tree. If we want to see all the tree structures of this, then it is also possible, right? Tree is available on Mac operating systems. Remember that one of the homework assignments that I asked you to do, if you use this tree command, then you can get it so quick, right? If you run this, for example, on top, cd, let's go to on top, and then tree, then this gives you all the structures of your file systems. So this is so great, right? But let's say Ubuntu or Ubuntu Mate, is there a tree command available? Probably not. Then you can still install it using apt-get. Of course, you need to have a sudoers, super user privileges. You cannot run this on lab server. On lab server, you are just a casual user. Then how can you practice some the system specific installation? Then you need to work on your Raspberry Pi. Okay, remember that you built your Raspberry Pi, and you are the super user by default because you are the installer. So as you install, okay, it asks you to create your. Oh, wait a minute. Oh yeah, it's Ubuntu Pi, Ubuntu Mate. Ask you to enter your login name and password. That is sudoers. Your name, your login is in the list of sudoers list. All right. So you can run, you can install tree, and then you can execute it. All right. If you have a very uh, deeper depth and wider width of your file structure, file system, then it takes long. See, I have a lot of stuffs on my Mac, so this tells you that. Okay, but anyway, there's the environment. So if you want to see env, then this is all the environments, right? If env is not working, then you can do print env. Both are working here, right? So all the variables are defined. All the pwd, then that is /users/jun, and home. See here, you will go somewhere there. If you type home, then it come back. Where? Home command is not found. Okay, what you can do then, home, then you can go home. Where is the home? Home users. Let's see, pwd users. This is not somehow. That's just home. So I need to say home, cd home. Then it can cd home. Then it can come back, right? So $home. Then that is the variable that. See here, echo home. Then that is home. If you do echo $home, then it it evaluates. It treats this as a variable, and then echo the content, echo the value bound to this variable. See here, env, you have a home here, right? It's defined that way. You can define also users, that is there. There's a path. You can see the path. Terminal, that is terminal set for this. And terminal program, there's Apple _ terminal. You can edit this. For example, I have a Python. See here, last time, which Python? Where is the Python? Python is that. And where is the Python 3? Let's see. Python, which that. Python 3. Okay. So I have Python. When I type Python, then it runs this user/bin Python. When I type Python 3, then user local bin Python. So Python 3 is in different directory, right? If you compare this and that. So, oh, it's now. How many files? 2 million, 2.5 million files. How many directories? 500,000 directories. Wow, that is what I have right now, right? So what is the size of ours? DF, disk information. The size of my it's about 1 gig. Is it about 1 gig? More. I think one. What's the size of that? So almost one. This is a byte, right? Kilo meg and gig, 900 gig. So I have 600 used and 400 available. So which is 70% used. That contains these many files. Okay, what I want to do here. When I type Python, then it runs this program. When I type Python 3, then it runs that one. So Python 3, oh, that is too long. Can I make a Py or P3? Let me see. You need to make sure that if there is any P3 already. Echo $P3. Oh, there's no P3. So we can make P3 equals Python 3. Okay, so that when I do echo P3, then there is a Python 3, right? There is a Python 3, and I want to export that P3 so that now I can run P3. For example, simply P3. $P3, then it runs Python of that Python 3, right? Quit. And if you want to unset that environmental variable, that is also possible by typing unset and P3. And after that, if you do echo $P3, then it's nothing there, right? Remember that when I hear echo P3, then it echoes Python 3. But here, the same command, after I unset, nothing here. That's part of aliases, right? So, oh, by the way, if you do this and export, and then print env, see here, it's there already. So when I do unset P3 and then print env, then there is no P3. This pipe we already looked at somewhere. PS, we looked at that, right? If we want to kill some, for example, let's say Python is running. So when I come here, PS minus AL, so that you can see Python here. Python is a process because it is running, right? So if we want to kill that Python, then this is a user ID. So I am running this, and that particular program, when a program is just a logical name, right? When program is loaded on your computer, then it is nothing but a process. Okay. um, of course, there's active process and passive processes, but this is a process. Process ID is 2326. Somehow, you cannot. Your terminal is hung there. Nothing that you can do. Okay, then you need to kill it. You can kill, you can open up another terminal and then take a look at that, and then kill, and then take that process ID 2326. See, terminated. It is terminated. There is a thing that you can do. All right, ls minus l. So when you do here, I'm going back to my home directory, and ls minus l, I have so many. So create the 231. So 321. So I created. Okay, back directory mkdir 321. Okay, so back here cd. All right, don't do that yet. Okay, 321. Where is the 321? So 321 here. So we have this kind of code. So D, as I said, D is a directory, and after that, I have 3 characters. Each 3 characters tells us something. So RWX 1 triple. Next triple is RX. W is right? It's not specified, which means it is not allowed. So read, R for read, W for write, X for execution. So in this case, RWX, all written there, it means all available. Users operation on the Linux systems are, include those operation, read, write, execute, read, write, execute. So somehow read, write, execute, allowed, permitted, and the next one read x, which means read and execution permitted, and then another 3 read x, which means read, write, permitted. Okay. So with that little observation, let's take a look next. Access permission, limiting unauthorized access to your directories and files is a very important concern for all Linux users. Is it only for Linux users? No, it is not. Is it effectively? Yes, in Linux. So for example, if some servers data breached, then it is breached mainly because of the platform. First of all, platform issue. It's not Linux, but Windows. Oh yeah, then we understand it is possible. Secondly, if data is written on a file system, file only, then files can be controlled by this. Okay, see, for example, this is a file. Okay, this is a file name. So for example, when I go to 321, nothing there, touch my first file. Okay, and then I can do echo hello mercy to my first file. Okay, and then if I want to see my first file, then that is there. And if we need to see that, then oh yeah, somehow it is, that one has okay, this one has RW and all so somehow readable, right? and writable, but not others. So if it is a file, if it is written on file, we can control the file um, at minimum fashion. But think about this: if that file is written on a database management system, some strong database management systems like Oracle is interoperable with the operating systems. So uh, of course, for the operating systems, database created by Oracle is nothing but a file, but it is not managed by operating system itself. It is owned by database. It cannot be open up without uh, other additional permits from Oracle, for example. And when Oracle allows you to open, then Oracle also monitor your behaviors in a way that it capture um, your session information, session user information. So it takes where you are from what IP address, and what is your role. Are you coming in my database as a simple user, or are you doing some others? And also based upon that, Oracle uh, gives you a permit to read a very restricted data set, so which is a small subset of database. Then Equifax breaches may not be uh, doable. Okay, it's more like management issue from the database point of view and then operating systems point of view. There are many others also. But anyway, that is the issue that we are going to do today. Okay, so how access control can be checked? When you come in, then you ask, request, can I read? For example, if you want to see what is the file? Okay, so can I see my first fat? This is a request. I wanna see that file. Okay, request. So there is a policy. Policy right now. There are also multiple different ways of the access control policies. This access control policies is really minimum way that you can do. There are some other like discretionary access policy and mandatory access policies. Basically, two ways of access policies. This is a mandatory access policies. So object specifies, hey, I am secret, I am top secret, and then user also classifies, hey, you are top secret clearance, or you do not have, and things like that. So those who has top secret clearance can access the top secret documents. It's not point to point. It's a class basis, right? That is a mandatory access points. But here is something like that, right? This has been long, many decades. And then since 20 or 30 years ago, there's another uh, uh, discretionary access control invented, and then uh, object and subjects stored separately, controlled separately, managed separately, and then there is a policy issues, policy management. So whenever a request comes in then policy management to decide whether allow or disallow. That type of things can be done. Yeah, quite a few of my research papers written on that and published in the top uh, uh, research publications about 10 years ago, right? Yeah, I don't do that since I joined Mercy, because Mercy doesn't allow me to do that serious research. And by the way, we do not have enough time, right? And right, Mercy does not allow me to spend all of my time on teaching. Teaching is partial, and they ask me to do many others. Hey, bring more students to Mercy, something like that, and they punish me. All right, so that is a mechanism. So there's a directory permission and file permission, but we don't need to say this a separate description on Linux, because why? Linux and Unix operating systems doesn't discriminate files from directory or directory from files. They're all the same. They're all file. Everything is file in Linux. So this doesn't make sense. But those who do not know Linux yet, you may think of this. But Windows system is different. Windows systems, folder is not really the same as file, right? They're all, well, their operating system is a little messed up. Okay. So how can you control this user access using change mode? Ch mode is a command, chmod, so change file mode or access control list. So the command is a chmod, right? So I want to read that, and the basic idea here is that you need to say who, change mode, who relates to user, group, others, or more, and operations and permissions. Example for that is here. If I want to, for example, I have only one, right? Ch mode, and I can do the owner of this, owner minus read. So owner can read this. See here, O means the user, and then plus or minus. So I want to take back the privilege of reading privileges from my first file, and then ls minus l, then O means others. I'm sorry. So it should be A. Is it A? Let me see. ls minus A. Yeah, it should be L. I'm going to give back chmod, and for others, I want to give read and my, okay. So what happens here is that, oh, by the way, now I need to tell you, these first three characters for the owner, and next three characters for the group where this guy is involved, and then last three here is all others. Okay, remember that I return back the read privilege to all others, all means others, so that this guy others has reading privileges, but me myself cannot read. Let's say I want to read, so cat my first file, It says permission denied. I cannot read. Even myself cannot read. It may be possible, right? For some reason. But because because I'm the owner, I can change it back, right? Say chmod, me myself, I want to give read permission to these particular objects, so that when I see this, I am now readable. So when I do cat my first file, then I can read it, right? See the same request, this and this. Okay, I have different uh, permission. Here, permission denied. Here, permitted. Therefore, this request, this action was taken. So that comes to not only other and myself a, but a group as well. This can be done in not only this. By doing this, you have to do for a one specific file. How many things that you have to do for a specific file? Then you have to do read, write, or execute for owner or group or others. So how many times do you have to issue this? You have to nine times, sorry, 3 times 3. Oh, this is 9. Oh, 9 times 3, so 27, which is hassle, right? So is there any simpler way that you can do? Yes, we have some numbering systems. Okay, so if read, then it is 4, and write, that is 2, execute, that is 1. Okay, so we assign number to each operation, and if we want to do read and write privileges together, then we simply add read write privileges, then 2 plus 4, then that is 6. If we want to give write and execution together, then 2 plus 1, there is a 3. If we want to give read and execute together, then 4 plus 1, that will be 5. If we want to give all, then 4 plus 2 plus 1, that is a 7, right? That's this describes here, right? If you want to do can all, actually can, right? Can all, then can do all, then 7. Can write and read, then 2 plus 4. So all the combinations, by assigning 1 to 4, there's no conflict with the number. Giving 1 to 4, if you add all possible combinations, then you will have 1, 2, 3, 4, 5, 6. All the number 1 to 7. That is possible. Okay, so one single number can handle 3 operations. And also, see, so 7. Let's say 7, then I want to give read, write, execute. Okay, that works for 3. If I give next one 5, then I want to give 5 can be obtained by what? 1 plus 4. 1 means execute, 4 means write, read. So I can grant execution and reading privileges to group, because the second 3 characters for group privileges, and then last 3 characters for the world. Okay, then if I give here, let's say 3, okay, then 3 can come from the addition, execution, and write, right? 1 plus 2, execution and write. So by having 3 numbers, each character, each number in between 1 and 7, then very nicely I can grant the access privileges to all three different groups for a specific file. And then ls minus l, and I have different privileges, right? This one, first three, as I said, 7, then all combinations. So I have all the privileges. And the next one is 5. 5 can come from 1 plus 4. So 1 for execution, 4 for read. So group can read and execute. And finally 3. 3 means these 3 characters. 3 means 3 can come from execute and write. So all others can execute and write, right? So all 27 possible settings can be done by this, my first 5. Okay. Now we have more. Touch my second file. Touch my third file. Okay, we can make touch your first file, touch your second file, and ls minus l, then we have those, right? We have those. So is there any way that I can do this? Guys, is not set the way that I would like to do, right? Can I, no matter how many, can I do all for the same privileges? Yes, you can. So we can save a lot of time if you type star, wildcard, okay, whatever available in the current directory will have that mode, access mode. That is also possible by having that command, enter, and then type ls minus l, then see, all have the same of those. Very, very handy, right? That's what, oops. So I want you to fill in here. For example, if I do this, if I have this, to make my file, this access control code, what command needed? So chmod and some number, and then file name, right? Number, what number? This is 7, execution 1, and execution 1. So if you do 711, then you will have this, right? So you want to see that here? chmod 711, your second file. Your second, or you second file. You second file. chmod 711 and ls u second file. See here, rwx dash dash x dash dash x. That's what we have here, right? This kind of things can be asked in your midterm exam, right? This is easy for you to do. By the way, midterm exam will be given to you this is my 5th lecture, 6th is next week, 7th. So yeah, after 7th. So 8th week, I'll give you a midterm exam, which will be okay. The 26th, that weekend, 26th. The midterm exam is not proctored by the school, college. You don't need to worry about it, but I can give you a specific time. We need to have some consensus, so you can solve it by open a Blackboard and open up course materials, that menu. Then you will see the exam button. I'm going to bring that exam button on top so you won't miss that. Okay, all details will be announced further. Okay, so that's what we did. Okay, UMask. Another issue here is that see, when I create this, right, by default it has all this, right? All has the same privileges, RW dash R dash dash R dash dash, right? I didn't do any specific grant to the file that I create, but as a file is created, automatically this privileges is given to that. Why? Because it is a set, the UMask. So, for example, print env. Say it is UMask is not really here, right? Echo yeah. If we type UMask, UMask is 0022. 0022. There's already set. This is UMask. What does that mean? What that number 022 or 0022 to us? There's a mask. Therefore, here mask represents a 3-digit octal number from 0 to 0 to 7, right? Octal number for permission to be denied. Okay. So less than 3. Let's consider less than 3 only. So 3 0 to 2. If you consider this 0 to 2, this is the way it is denied. So actually, real permission is that you have to subtract the octal number determined above from octal number 777. What does that mean? So Python. So if you subtract each 7 minus 0, there is 7, right? And then 7 minus 2, that is 5. 7 minus 2, that is 5, right? What is a 755 in CH mode? Let's say right now this is me, right? This is what we changed by 711. So if I do CH mode 722 to U to file and ls minus L, then that 755 U mask 022. So 777 divided by that, then 755. 5 means, what is here? Oh, I changed that, right? So let me touch one more and touch her one file. See what it is. Touch her one file this. this read, which means R means 4, right? 4. This doesn't follow that actually, but the idea here is this: use the command umask local number, then that is a set. Therefore, if you want to the permit to grant 744, then umask needs to be set 033. Therefore, whenever a file is created, it is created with the permission of the subtract 777 minus 033, which is 744. So all the files will be written in 744. That's what this umask works. But somehow here the Mac is different, a little different. So the code used for the permission, when I create one file, this is read means it's 4, and 4 and 2, so 644. Oh, so it is not subtracted by 777. It is subtracted by 666. Oh yeah, that is it, right? Here in this case. So umask is this. So if you subtract 022 from 666, then it'll be 644. 644 is interpreted this. 6 means read and write, 4 means read, and 4 means read. Okay, so if I make not, if you want to make if you want to make all the files in this way, like this, so this all privileges and read and execute privileges. Read and execute, that is 4 plus 1, so 5. This is a 755. So just divide by, this might not be possible, right? Because 6. It works on the real Ubuntu and Linux. This is a little tweaked by here at Mac. So I want you to also practice this on Linux, okay? Not the Mac Linux. Raspberry Pi, for example. It should work. What happens is that you set umask differently. Say 133, 0133 in this case. Then umask is 0133. So after that, if you want to, where am I? WD. I'm going to do 321 ls. Okay. If I do touch, if I want to maybe touch, because of a touch command, let's try here. If I do vi per second file, so that I simple file, and then I save it. What is per second file? The same thing, right? So here, when I type third file, ls minus l, third file. Well, it is strictly restricted somehow here. So I wanted to practice that. Raspberry Pi. All right. I think this is it, right? Okay. So I will see you next week.